Okay, good morning, Year 9. I'm just going to wait for everybody to arrive. This should be the triple webinar. I can see numbers popping up nicely. I will share the slides once we've all got in. Give me 2 seconds, just checking for Mr. Collins. Hello, guys. And Mr. Collins is here, ready to answer any questions, put them in chat. Thank you, people who I teach, for saying hello. I'm going to give it a little bit longer just to let everybody arrive. Then I will share slides and break down what we're doing. If some of you may or may not have done what we're doing today before, but we're just trying to make sure everyone gets to the same page, if that makes sense. Okay. Okay, it's 1 minute past, so I'm going to start sharing. By the way, before I do start, thank you for all your hard work last week. There have been some excellent responses on the Google form and in the Google classrooms, and I've heard this from all teachers of the triple classes, so thank you very much for all your hard work. It is not going unnoticed, and we do appreciate it. Right, I'm going to share my screen now. Bear with me for a second. It's probably going to share something a bit weird, just because I've got to click over. There we go. And give me 30 seconds just to scroll, because I was adding some wonderful links for you all earlier. Okay. Hopefully we can all see what's in front of us, which is just the timetable for your week. So just a reminder, this morning you have your webinar, which is from now until the latest of 11:45. And then on Wednesday, you're expected to complete some tasks in the Google Classroom, and I will go through these shortly. And then Thursday, there is another task to go into your Google Classroom. You'll also notice at the bottom of this first slide is the link to the YouTube channel. And on there, you can find any of the webinars that we have done this year, as well as webinars from last year and various links that we've been putting in that we think will be useful for you, be it free science lessons or fun things to do and so on. Okay, hopefully there's no questions on that. I'm not sure if Mr. Collins is able to actually jump in and tell me if there was any questions. I'm sure he will message me via computer emails if need be. Okay, I am going to bounce us on to the next slide. So this is just so you know what is happening and to break things down for you. So during this webinar, the first section that we're going to go through is feedback from last week based on the Google form. And I've got a lovely video from Miss Boots to show you some of the areas we saw needed to go back and be looked at. I've then done a webinar poll to just check you were listening to that feedback. I'm then going to go through bonding, so covalent, ionic, metallic, as well as ionic structures and metallic structures. And then after that, there is a question which I will talk you through, and I've provided a mark scheme for you to complete it after the webinar, as well as another question on there for you to complete after the webinar, which your teachers will give you feedback for. Give me 2 seconds. Okay, apparently you guys can't see the slides, so I'm going to just try a stop share. And I'll try sharing again. Thank you, Mr. Collins. Let's try this again. I'm going to wait. And Mr. Collins, if you could remind me how to promote you to panelist, I will gladly do that right now. I've forgotten some of the technology, and anyone who knows me knows that I get a bit flaky when it comes to this sort of stuff. So apologies. Actually, I think I may have remembered. Bear with me for 30 seconds. I'm just trying to find Mr. Collins. Mr. Collins, that should have been done for you. And it looks like it has. You're just on mute. Okay, very quickly, I will jump back. So this was the first slide I was talking about, and apologies that you couldn't see it. Hopefully you're seeing everything fine. This is just, as I said, the timetable with the YouTube link. I believe I am recording, Mr. Collins. I did hit record. Yep, I am recording. So it's got me faffing. Okay, so this is the remote learning page with the YouTube link. And then this is the timetable that I was just talking through. And this is just so you can see how long things should take and what to expect during the webinar. I'm going to get to moving and get started. So the first bit I would like to do is show you a video that Miss Boots kindly made. I'm hoping this is going to work well. I'm just going to load up the video now. Bear with me. Mr. Collins, if you could let me know when you can see it. I am struggling to get the links right. Escape, hang on. There we go. Can we all see YouTube? That is my question. I saw a raised hand. I don't know if that was you trying to tell me. Mr. Collins, can you see a black screen? You like my voice right now, Mr. Collins? Yeah, awesome. Thank you. Right, I'm going to hit play.
Miss, I think the sound isn't working very well on that. I'm certainly not able to hear it. I don't know if others in the others in the chat are saying they can't hear anything. Maybe if we post that video up onto the classrooms afterwards, that seems to be the best way to work that.
Okay, thank you. Awesome. I did wonder about the sound, sir. So, okay. So there is a video there. And Miss Boots has kindly gone into lots of explanation with all the slides. I will very quickly click through. I'm not going to be as detailed as Miss Boots, I'm afraid. So if you do need to go back over this, then you will obviously have a link to the video in the slides, and I've added it to the last slide for you. So we've got how to calculate protons, neutrons and electrons, and this was one of those tricky questions that we put in, and I think I put iron in, and it had a bit of a decimal point number which confused some of you, as well as some really weird answers came up, but that's all good. This is why we're doing this now. On the left you should see the structure of the atom, and we've got our protons and neutrons in the middle, and that is where we get our mass. If you look at the table, it says mass of 1, mass of 1. So the mass is always in the nucleus. We've then got our electrons floating around the outside, and they're very, very, very small. So we say 1/2000, or you can say very small. And then just as a recap on charges, protons, P for positive, electrons are negative, and then I always remember neutrons as neutral, which means they do not have a charge. Okay, so to remember and find out how to work out the numbers, we've got the proton number, which is the smaller number, and then we've got the atomic mass number, and as Miss Boots correctly wrote, and I like this, massive number. So the bigger number is the mass number, and linking back in, where you have your mass is your protons and neutrons. So that number is both protons and neutrons. Okay, now, this is how we calculate them. So protons is simply the proton number, the smaller number. Neutrons is the big number, the massive number, minus the protons, because the mass is protons and neutrons. And then electrons is the same as the proton number in an atom, because they cancel each other out to make sure our atoms are neutral. This was the question in the paper, and you can see this was my fault. I struggled to find a rounded up number. It was 55.85, but we obviously can't have 0.85 of an neutron, so you had to round it up. So 26, so we'd do 55 or 56 minus 26, which would give us 30, which was the answer of the number of neutrons. And I believe most of you got protons and electrons right. It just went a little bit tricksy on the neutrons. Okay, we then had a bit of a muddle with group number, and again, this was probably because I put a trick question in. There are 8 groups, 1, 2, 3, 4, 5, 6, 7, and then 8 or 0. And then we have the transition metals breaking up groups 2 and group 3. And the group number corresponds to the number of electrons in the outer shell. So you can see over here, we've got lithium, which has 1 electron, so it's in group 1. And then chlorine has 7 and is in group 7. And then oxygen would have 6, nitrogen would have 5, and so on. So the group number is the number of electrons in the outer shell, and there are only 8 of them. Okay, and that's what this slide says. And then this was the question, and some of you put 18, and the reason I'd put that in is if you count across the periodic table, there are actually 18 rows, but we only have 8 groups. And then this was the third question that needed feedback on. So the melting and boiling points of group 7, and the melting point and boiling point of the halogens increase, and you can see this from this lovely graph Miss Boots put in, as you go down the group, and that's because the molecules themselves are getting bigger, which you can see at the bottom right, and then the intermolecular forces become stronger. Now that's the force between 2 molecules. And that force becomes stronger, so you need more energy to break that bond, so between 2 chlorines or between 2 iodines and so on. Okay, and this was the question, so why does iodine have a higher boiling point than chlorine? And the correct answer there was because the forces between the iodine molecules, the separate molecules, are stronger because there's more electrons involved. Okay. I decided to make a poll. So again, I am remembering how to do this. So this is going to be your first poll question. And again, I struggled to find a rounded number, but I have told you how to work that out, round up or round down. So I am just going to try and get the polls. I am going to launch poll 1. Hopefully that is now appearing on everybody's screens. And the question was, how many neutrons are present in the following element? The element is calcium, and you are all doing absolutely amazing on this. Okay, I'm going to give it a little bit of a second. Welcome everybody, by the way. It's nice to see the numbers are really good. I'm going to give it so that we've got most of us have voted. Remember what I said earlier about part of an atom? We can't really have part of a neutron. Okay. Okay. Awesome, that's just flew up. So I'm going to end that poll now. Don't worry if you haven't been able to. Now I'm just going to share. Lovely that 81% of you have got 20. For those of you who did 20.078, that links into the iron in that we can't have part of a neutron. So you can't have a bit of a neutron. You either have a whole neutron or not. And because that number is so low, so it's 0.7, we would round down to 40. So just be aware of your rounding. If it said 40.52, we'd round up, but because it's below that 0.5 cutoff, we'd round down. Okay, excellent. And I'm going to click on because we have another poll. I'm just trying to click my slide on. There we go. Question 2. This is just to check you were listening. How many groups are there in the periodic table? Hopefully, again, that's popped up. And again, you've gone really nippy on that one, which is excellent to see. I'm going to end that one in a second because we're nearly all there. Yep, I'm going to end that one there. I'm going to share the result, and amazingly or wonderfully, 86% of you got the correct answer. It is 8. For those of you who are still struggling on why it isn't 18, do have a look at the YouTube video on the feedback, which does explain it more than I have just shared with you. Okay, and I'm going to click on to the next question. So question 3, why does chlorine, I may have muddled this one around a bit for you, by the way, why does chlorine have a lower boiling point than iodine? The forces between the molecules are weaker. Chlorine is more reactive than iodine. The covalent bonds are weakened, or iodine is covalent and chlorine is ionic. I am going to launch that one. Good to see all the responses coming in. I do hope you're enjoying the polls. I wanted to give you a bit more interactive, interaction with the webinars. That was what I was going for, but it all went a bit muddly then. Okay, I'm going to give it 2 or 3 more seconds. Okay, so I'm going to share that result because, again, it's a little bit wobbly. 50% of you have got the correct answer there, in that the forces between chlorine molecules are weaker. I'd literally switched the last question about iodine round. Chlorine more reactive than iodine, and then we've got covalent bonds weaker in chlorine. I can see where all these thoughts come from, but it is all to do with the intermolecular forces between chlorine or iodine. So again, I'm going to suggest after this webinar, if you have time, have a look at the YouTube video link that is on the end of the slides, linking to the feedback for the quiz. And if that doesn't help, please do email your teachers. Okay, now this question wasn't on there, but I've put this in because it links in nicely to what I would like to go on to today, and I want to see where you're at. So question 4 is, what is an ion? Okay, and then we have, it's an atom with a neutral charge, an atom which has lost or gained an electron and has a charge, something to straighten the periodic table, or a metal with a charge. I'm going to launch that poll there. Hopefully, again, that's popped up. Yep, I can see some results, and excellent. So what is an ion? I-O-N. Okay, I am going to stop that one there because I think we're all generally done. Okay, and I'm going to share results, and excellent work, guys. 92% of you have got that an ion is an atom which has gained or lost an electron, and that's going to link in lovely to what I am going to do next. So thank you so much for that. Okay, so I'm just going to keep here for a minute. So I'm going to run through bonding. I'm going to probably go quite quickly because I don't want to keep you here too long. I'm going to start with ionic, then covalent, then metallic, and then I want to do a little bit on structures of ionic and metallic before I explain the task at the end. Obviously, I am going to go quite fast. The idea is that you can re-watch these webinars and make notes at a later point, and that they are available to you after this broadcast so that you can use them as and when you need them, and they're not just a sort of one-hit wonder. So this is ionic bonding, and I put 2 pictures on because I thought I'd talk through the pictures. The bottom one is where I'm going to start, which is the magnesium and the oxygen to make magnesium oxide. And I want to start by talking about, these are the atoms on the left, and then these would be the ions in the ionic compound on the right. Now you can see magnesium here has got 2 little X's on the outside, and all atoms want to get to a full outer shell. So magnesium will want to lose those 2 electrons so it has a nice full outer shell and feels more stable. It's all about becoming stable. Oxygen, on the other hand, you can see has got 6 dots on the outside, so it wants to gain 2 electrons to become stable and fill that shell. And generally speaking, in fact, it's not generally speaking, it is speaking, the metals will lose their electrons, and the non-metals, which is oxygen, will gain electrons. And then in this case, magnesium has lost those 2 electrons, and we put brackets around to show it's the ion, and then it's lost 2, so we get a 2+ charge. And then we have oxygen has gained 2, and it becomes 2-. Now, in terms of the charges, when you lose an electron, you're losing negativity, so you become positive. And when you gain negativity, you become negative. So we often talk in science about emotions. If you gain negativity, you're going to become more negative. If you lose it, you're going to become positive and happy and bouncy. So that's that. You'll also notice with both of these diagrams, one has got dots and one's got crosses, and that is to just make it nice and clear about what's going where. At the top here, we've got the ionic compound. So we've got bonding in sodium chloride. Sodium's in group 1 of the periodic table, so it's just lost 1 electron, which you can see has been added to the chloride ion here, which has got a negative charge because it's gained 1 electron. This is the basics of ionic bonding. It is the gain or loss of electrons. Metals lose, non-metals gain. And because I wanted to make sure you had everything nice and clearly, on the next slide, I've put the key points. So ionic bonding occurs between metals and non-metals. And then in brackets, I'll put that be groups 1 and 2 with 6 and 7. And you'll notice again, magic number 8. So 1 plus 7 makes 8, 2 plus 6 makes 8. There can be some complications to that, which I will go through with you. So, for example, if you've got a group 6 non-metal with a group 1 metal, you would have 2 group 1 metals joining with 1 group 6 metal, non-metal. Excuse my language there. Lose is metals, gain is non-metals, and that's electrons. They are held together with strong forces of attraction, which is going to link into structures later, and they will form ions with charges. So +1, -1, +2, or -2. Okay, hopefully you have understood all that. I'm going to move on to the next bit. So this is covalent bonding. Now, covalent bonding is non-metals only, so it's only ever on the right-hand side of your periodic table. And this is the sharing of electrons. And I've put 3 pictures on here, and I've started with hydrogen. So hydrogen, we know, has 1 electron in its outer shell. And for hydrogens to get a full outer shell, like helium, they need 2. So you can see here we've got 2 hydrogens and they are sharing an electron in each. Okay, and that's what that means. You can either do them on the edges like they've done on this picture, or like the ones I've got on the right, which I'll talk through in a minute. We've then got at the top right water, and we've got oxygen, which has 6 electrons in the outer shell. So it joins with 2 hydrogens that both share in 1 electron. And you can see if you count round oxygen, we've got 1, 2, 3, 4, 5, 6, 7, 8. And that would always be a tip of mine. Check they have a full shell when you're drawing these sort of things. Check there's 8 if it's a large one, or 2 if it's hydrogen. And they are both sharing. So that's the share in the middle there. And I quite like the middle because it's nice and clear. Again, you'll notice dots and crosses. So oxygen is dots and hydrogen is the crosses. We've then got oxygen at the bottom, and I've put oxygen in because oxygen is has 6, so it needs to form what we call a double bond. So each oxygen shares 2 electrons, and that makes them very, very strong. Covalent bonding, and it also means they get a full shell. And again, if you count round, we've got 1, 2, 3, 4, 5, 6, 7, 8. And it is all about getting to that magic number of 8, or in hydrogen's case, 2. Okay, and again, I've put bullet points in. So covalent bonding is between 2 non-metals, and they are on the right side of the periodic table. I always recommend using your periodic table with these sort of questions to locate what you're looking at, because then it will tell you if it is going to be ionic or covalent. They share their electrons. Each shared pair forms a covalent bond, and they can share more than 1 electron, which is why I put oxygen in, because they both share 2, which makes 2 covalent bonds. Okay, last bonding is metallic, and metallic bonding is to do with the positive ions. So you can see here we've got our positive metal ions arranged in layers, which I'll talk about a little bit more shortly. And then we have our freely moving negative electrons in the outer shells of each atom, and they are called delocalized electrons. That just means they're not local. They don't stay with the atom they're at. They're delocalized, so they can move around. I like to think of it as if it was local, it would stay in Brighton, but these electrons can move to Worthing and New Haven because they're delocalized. They're free to move. And that's what makes metals have the properties they have, which, as I said, I'm going to talk about very shortly. So metallic bonding, the key things you need to know is the atoms in metals are closely packed together and arranged in layers. So if I click back, you can see they're nice, neat layers. Nice neat rows, much like our solid diagrams from year 7 when we talk states of matter. They have a positively charged metal ion which is held together by the electrons. So those little electrons that are free to move are holding them together. And then the delocalized electrons are free to move throughout the giant metallic lattice. And that's your key point here. Delocalized electrons are free to move, and that's why they can carry charge or carry energy. Okay, so that is our 3 types of bonding, very quickly run through. I'm now going to move on to structures, and I'm aware I'm going through information fast, but as I said before, the idea here is that you are able to come back to these and watch them and make notes. Okay, here we have our ionic structure. This is a giant ionic lattice, so they may ask you to call it a giant ionic lattice. And you can see that it makes a big structure of alternating atoms. So if we had sodium chloride, we'd have sodium, chlorine, sodium, chlorine. There are strong electrostatic forces between the charged ions. So if you think charges, positive and negative attract, so you get a strong electrostatic force. This means that these structures are solid at room temperature. They have high melting and boiling points, and they need lots of energy to overcome those bonds. And those are the main key points for ionic structures. So if I click on, again, I've done a slide with the key points. High melting and boiling point, lots of energy needed to overcome the electrostatic forces of attraction. That's what we call that attraction between the positive and the negative. They're all solids at room temperature, and they will conduct electricity when they are molten or dissolved because the ions become mobile and can carry charge. Now, on that last point, what that means is when you heat this, you break the electrostatic forces, or when you dissolve it and it becomes a solution, you break the bond between the positive and negative. And that means these negative ions become free to move around the solution and carry charge. And that becomes important later on in chemistry 1 when we look at something called electrolysis. Okay. So that will conduct electricity when molten or dissolved. Hopefully we've understood that. The key there is because the ions become mobile and can carry charge. Okay. Metallic structures then. So I've already kind of covered most of this on metallic bonding. The 2 link in quite nicely. So we have our positive ions with, again, with that C of mobilized, delocalized electrons, and they are free to move and carry charge. Okay, so mentioned layers already. The key thing with a metallic structure, and I'm not covering alloys today, I believe Mr. Collins will do that next week maybe. Metals can be bent or shaped because they have those layers, the straight layers which can be moved, and it's because those atoms are able to slide over each other. So they're not very strong, and it's why if you look layers, it's why things like gold tend to be an alloy. There's actually something mixed in to make your gold jewelry stronger. And those delocalized electrons in the metal enable electricity and thermal energy, so heat energy, to be transferred. Do be careful on metal structure questions, because some people talk about electricity when the question's asked about thermal energy. So do make sure you're aware of which topic is being asked about. Is it energy or is it electricity? Because your answers will be slightly different. Okay, that is all the content that I wanted to run through today. The next bit is that we wanted to talk through some questions. So as you can see at the top, it says structured questions, teacher explanation, students complete after and self-marked, and then a question for you to complete. So the question that I was going to talk through is this one. So it says magnesium chloride contains magnesium ions, magnesium 2+, and chloride ions, Cl-. Describe in terms of electrons what happens when a magnesium atom reacts with chlorine to produce magnesium chloride. Now, the reason I've chosen this question and these type of questions is the answer is pretty much the same format. It just varies depending on what metal and non-metal you are looking at. So we've already been told magnesium chloride is magnesium 2+. That means it's going to have 2 electrons free to give or lose, and chlorine is minus, so chlorine needs 1. Okay, now you can see the number issue there, that if magnesium gives chlorine 1, it's still going to have 1 left. So what you would start with is saying magnesium loses 2 electrons and chlorine gains 1 electron, but there are 2 chlorines gaining 1 electron each. So you need to recognize that there will be 2 chlorine ions both gaining 1 electron. And the key is to recognize what goes where. So 2 electrons are lost from magnesium and 2 chlorine ions are gaining 1 electron each. It's really important with these sort of questions that you talk about the numbers involved. So if you put magnesium loses and chlorine gains, you're not going to get the marks. But if you have that magnesium is going to lose 2 electrons and chlorine is going to gain 1 electron each, and there will be 2 chloride ions, then you will get the marks. And hopefully that was a clear explanation for you. And I have put the mark scheme for that question under here, so you can have a go yourself and then self-mark it. It's on the notes of this slide for you. This is the question that you're going to complete on your own, and then the teachers will mark back, and you will notice it's exactly the same structure, just different ions involved. So magnesium iodide is an ionic compound, contains magnesium ions and iodine ions, and describe in terms of electrons what happens when magnesium reacts with iodine. So this is the question on your webinar slides for you to complete and that your teachers will mark back on. I've also put some other exam questions together as additional work should you not have enough with this one question. Okay, this is your useful links page. That is the YouTube link for the feedback. There is another link at the bottom, and I have another few links that I need to add in there for you. So they will continue to be added on for you. At this point, I'm going to ask if anybody has any questions that they would like to share about the work or the information, and open it to a Q&A session with me and Mr. Collins. And I am also going to stop recording because we have finished the content.